Hello my dear friends, welcome to IMS GATE Academy. I am Sourav Upadhyay and I welcome all of you to this live session of fundamental series where we are discussing the fundamentals of every important chapter as far as your GATE is concerned, and I am sure that you are enjoying these sessions as well. If you do find it useful, please share it with your friends and invite them as well. Now my dear friends, yesterday we were discussing about the fundamentals of network models, wherein I discussed that what is the basics of, what are the events, what are activities, what are the small things related to a project, what is dummy activities, now what, how can we construct the network models, what is Fulkerson's rule, and then at the end I took a network model and I analyzed it. We analyzed it very neatly, and I told you what is float, what is slack, and what is meant by the total float of an activity, independent slack, free float, all these things we discussed, forward path computation, backward path computation, all these things we discussed, and finally we concluded with the critical path of a network model, and I am sure that if you have seen that session completely, you will be gaining a lot. Fine. On that respect, proceeding from today, my agenda is that today we will be discussing about the basics of PERT. Firstly, we will be discussing about the basics of PERT, and then the most important topic for today would be normal distribution. My dear friends, why normal distribution it becomes so important when your overall gate is concerned and not only your industrial engineering is concerned. Firstly, this normal distribution is a very integral part of your mathematics, engineering mathematics. You will be, it's it's a very, you can almost expect a question from there every year, no matter whatever branch you are. Secondly, in industrial engineering, normal distribution have its many applications. Now the first one we will be seeing in PERT, and secondly I will also show you that how it is used in the probabilistic model as far as your inventory control is concerned. Yes, it is applicable in the inventory models as well. So firstly, I will be starting with the PERT basics, then I will be in detail covering the normal distribution, and then I will show you that how it is useful in your inventory models as well, right? So my dear friends, without wasting any time, let us proceed, or let us start with the topics. My dear friends, as far as yesterday whatever cases we dealt, as far as when I say the CPM model, critical path method model, therein my dear friends, sometimes what happens, your project is very certain, you know that your project would be completed in this much of time, and whatever we did, the float, slack, and your critical path of a project, whatever we did, the days were very much known to us, and we were very easily able to calculate the critical path of a project because everything was certain. For example, you are doing a project for so many number of times, so you are already familiar with the time taken to complete the project, and therefore it becomes so easy to say that okay, this will take this much time, this will take this much time, and this will take this much time, for an example. Sometimes what happens, you work on a new project, for example, if we are doing research on a new medicine, if we are doing research on a new project, for example COVID vaccine, for example if our esteemed institutes like ISRO, research institute ISRO, DRDO, they are working on a new missile, they are working on a new satellite, and they don't know how much time it will take. So anything, if you are doing for something for the first time, then you are not certain about the time which it will require to complete the project, and that is where this PERT comes into picture, program evaluation review technique comes into picture. So my dear friends, you can clearly see that I have written here concept of 3 time estimates. Why the concept of 3 time estimates is required? Because you are not certain about anything. You don't know when this project will complete, when this activity will get completed, and so on and on and on, right? So my dear friends, I will be taking an example. For example, just consider that there are 3 candidates over here. What is my aim? My aim is to firstly find out that an activity takes how much time, and finally my aim is the same, the final aim remains the same, that is what is the on an average time required to calculate the project completion time. So my dear friends, suppose that we are working on a new project and there are 3 persons over here. So if we ask the first person and we are dealing with an activity, I am concerned about an activity that this will take how much time? I don't know. Why? Because I am doing this for the first time, and let's say I have started, this is my event 1, I have already started working on I am started working on an activity. I don't know how much time it will take. I don't know. This means I completely don't know. So what will happen? I will ask person number A, and then I will ask person number B, and I will ask person number C. So there is mostly you will get 3 types of person. Person A will tell that sir, this activity that you are on working, it will be finished very early. No restrictions will come. Everything will be good. No, you will face no difficulties, and you will be doing it, let's say in 1 month itself. It means he is so optimistic about the thing. He feels that no problem you will face, everything will be very smooth, and you will complete this project in 1 month. Person number C will feel that he is very pessimistic type of person. He will feel that sir, when you will start working on this project, you will face so many difficulties. Rain will come, electricity will not be there, this will some kind of hamper will happen, and therefore sir, you will take a lot of time. Let's say you will take 9 months. So there is such a gap between 1 month and 9 months. And the person with a balanced approach of mind, balanced thoughts, he will say that sir, considering all these set of some difficulties will also be there, sometimes the process will be smooth also, we will means considering every aspect, let's say this project he will feel that the project will complete in 5 months. And we all know, if we apply our intuition over here, we all can see that yes, mostly there is a chance that this whatever B is saying, this should be correct, because he is applying all the he is considering every pros cons related to a project, and it will be done in somewhere around 5 months. He is not saying exactly, we cannot say exactly, yes, we cannot say exactly. Why? Because we are using probability here. Whenever probability comes into picture, uncertainty comes into picture, you cannot say something is happening in an exact manner. There is some kind of chances, we are all talking about chances over here. Now my dear friends, you will say that, you will feel that sir, let's take this 5 month itself, because he is having a very balanced approach, let's take his word only. But my dear friends, probability is all about chances. It can be 0.001%. If there is a 0.001% chance of happening something also, you need to take that into account as well. So I will not discard this also, I will not discard this also, and as such I will consider all the 3 time estimates which I need to find the expected time for this activity. So my dear friends, this is the concept of optimistic time. This is the concept of optimistic time, that is person number A. Pessimistic time, that means person number C, and most likely time is the person number B. And now my dear friends, I'll be what I'll be doing, I'll be giving, I'll not give all the importance to 5, that is person number B. I'll give maximum importance to person number 5, but I will also not discard these A and C. I will also give some weightage to this. Means this can also happen, this can also happen, this can also happen, but equal weightage I will not give to all of them. I will give maximum weightage to the person number B and some weightage for A and C. And this is where the concept of expectation comes into picture. Expected time comes into picture. And my dear friends, when I say that what is the expected time, now that you have taken into account the saying of every person, now you are in a position to find out what is the expected time. And what is the expected time? I have given, let's say this time is TO, that 1 month is TO. This pessimistic time is TP, pessimistic time, and most likely time is TM. So my dear friends, I will be giving 1/6 weightage to optimistic time, 1/6 weightage to pessimistic time, and 4/6 weightage to the most likely time. And as such, your time formula becomes T naught plus 4 Tm plus Tp divided by 6. And it is nothing but, if you recall the concept of expectations, it is nothing but I have written in the expectations form. Why? Because expectation formula is summation x px. Yes or no? So I am only finding the expected time. Expected time means expectation, summation x into px. This is your x. In place of t, you can assume x. In case of px, 1/6, 4/6, 1/6, you can see that it is nothing but written in terms of probability itself. So this becomes the first formula that we are interested in finding the expected time of an activity, and this is your expectation time. Now we know, and I can say that this is completing at 2. My dear friends, also I would like to tell over here that in PERT, we generally say that PERT is event oriented. Why we say it is event oriented? Because we don't know anything about the activity. We have to depend on 3 time estimates for finding the expected time. That is why I say that, means I know something is finished only when we reach the event. We are dependent on event completion rather than activity. That is why we say that PERT is event oriented, right? So this is all about the concept of 3 time estimates. Now my dear friends, this was all about an activity. Not all. One more thing is left. I will tell you now. But before that, my dear friends, we should understand that the 3 time estimates, it follows beta distribution. Yes, the 3 time estimates you can see here, my dear friends. This is the curve for a beta distribution, and this is the optimistic time. That means he is saying that I will be finishing this as early as possible. Pessimistic is saying that I will be completing as late as possible. This is the most likely time, and see, you can clearly see that this expected time is very close to your most likely time. So it makes sense also that yes, B was having a very balanced say. So this must be around the whatever B is saying, somewhere close to this only, right? Is it clear till now? Is it clear? Is it clear? Fine. Now my dear friends, I would like you to recall that in mathematics, whenever for a distribution, you calculated 2 things. First, there was the mean value, and second, there was the standard deviation or variance. Why? Because first is telling you that what is on an average, whenever there is data with us, let's say there is a lot of data with us, what do? We always are interested in finding 2 things, that is where is the middle value line, and second, how are the data arranged with respect to the mean value, and that we call as standard deviation, that we call as variance, and that we also call as range, dispersion, all these things we say. So generally we are interested in two things. So for the activity you already calculated one thing, and that is your expected time. Now is the time to calculate the second thing, and that is range or the standard deviation. So my dear friends, over here in this case the standard deviation, or that we denote by sigma, is given by the range. And what is the range? The range is, here is TP and here it is TO. So we directly take the difference. Range का मतलब क्या होता है? Range means the difference between the extreme ends. So that is why the formula becomes TP by 6 minus TO by 6, and this we write as TP minus TO by 6. What is this 6? This 6 is nothing but the weights associated, the weights that we attached to this time. My dear friends, you know from your basic mathematics that whenever you have the standard deviation for any data, it's very easy to find the variance. Variance is nothing but the standard deviation whole square, and that is the sigma square. Fine. So for an activity, now you have three things. What three things? If I give you an activity with 3 time estimates, you will be very easily able to find what? The expected time, number 1, number 2, the standard deviation, and number 3, the variance for a single activity. For a single. So this we have concluded. I'm just writing the formula for the final conclusion part. Whatever we have understood, that suppose there is an activity with us. Let's say this is activity A, and it is having an expected time of TE. It is starting at 1, it is ending at 2, and this A is having 3 time estimates, which is TO, and then this is TM, and then this is TP. So what things we have find out? That what is the expected time for an activity? It is T naught plus 4TM plus TP whole divided by 6, number 1. Number 2, sigma we have found out, and that is TP minus TO by 6, and number 3 we have found out variance. See, I am writing here x because generally in mathematics you will see that variance of x, right? So variance is nothing but your sigma squared. Now my dear friends, see one thing. This was all about one activity. Now is your project comprised of only one activity? No, it is comprised of so many activities. Yes or no? So my dear friends, your project is comprised of many activities. So for every activity you need to calculate all these three things. Yes. For example, let me give you an example that let's say this is 1, this is 2, this is 3, this is 4, this is 5. Let's say this is A 5, this is B 6, this is C. Let's say this is B 6, this is C 7, this is D 8, and this is E 9. So 7, 5, 12, 12 and 9, it is 21, and this is 6, 8, 14, 14 and 9, this is 23. So my dear friends, this becomes your critical path. this becomes your critical path. Yesterday I have told you that whatever is the longest path in your network diagram, you can say that is your critical path. So your critical path is 1, 3, 4 and 5, and the duration is 23 days or whatever. So my dear friends, in PERT, you will be given the 3 time estimates corresponding to this, the 3 time estimates corresponding to this, 3 time estimates corresponding to this, 3 time estimates corresponding to this, 3 time estimates corresponding to this. You have found out the expected time. Now what is all these things? 5, 7, 9, 6, 8. What is all these things? These are nothing but your estimated expected time. Expected time. So you have found out the expected time, and after finding the expected time, you have got that 23 is your critical path duration. My dear friends, or the project completion time, whatever you want to say. Let's say this is your project completion time. This is your project completion time. My dear friends, they can also ask you what is the variance of the project. Yes, they can ask you what is the variance. So variance will be the sum of the individual variance of all the activities which are lying on the critical path. I repeat, variance of the project will be the sum of the variance of the individual activities which are lying on the critical path. It means if I say what is the variance of this entire project, so you will say that sir, it will be variance of B activity. So see, I have written standard deviation and then I have written whole square. Why? Because variance is a whole square of standard deviation, plus then I will say variance of D and then whole square, and then I will say variance of E whole square. This becomes the variance of the activities which are lying on the critical path. For variance of the entire project, you are not going to include the non-critical activities. Fine. Sir, how to calculate? See, individually you can find out the variance of the activities, and then if you add, it becomes the variance of the entire project. So till now, what we have discussed, that in PERT, whenever they have given a project, you will be able to find the project completion time, and then you will be able to calculate what is the variance of that entire project. What does variance tells us? Variance generally tells us the uncertainty related to a project, the spread in the project, how the data are arranged from the mean. But on a broader level, the broader sense of variance is uncertainty. Variance signifies the uncertainty which is related to any project. My dear friends, why we are finding this? You must be wondering that sir, when we have completed this project completion time, when the project is completed, why are we finding the variance of this project? My dear friends, I will tell you that it has got a very high significance, that why we are finding. First of all, it is telling us the uncertainty that the project can be completed in this much time, this much time, this much time. So the picture is very unclear over here. But now when I tell you that we are dealing in probability, this is all about the probability, and there is very much uncertainty. That means I cannot say with certainty that my project will be completed in 23 days. Yes, it's a very important statement, my dear friends. You will feel that sir, we can say now that this is 23 days the project is getting completed. So where the angle of probability has come over here? No, it's there. First of all, I cannot say with certainty. With certainty means 100% certainty that this project will be completed within 23 days. I can say with a certain level of certainty. How much certain level? How much this? This is the first question. Second question is, When it is not certain that 23 days may your project will get completed, so it means the project can get completed in 24 days, it can get completed in 25 days, 23 days, 19 days, 30 days, anything is possible. And any day is associated with some level of certainty. It means if I am saying that the probability of project completion is 23 days with a certain level of certainty, so it means I can also say that the project will get completed in 30 days with some other level of certainty. So what is all these about? And now when I say the statement, this statement is perhaps the most important statement in your entire PERT, and this, my dear friends, is the project completion time follows normal distribution. The most important statement over here is that the project completion time follows normal distribution, follows normal distribution. Fine. So now, my dear friends, our motive is that we need to understand what is normal distribution, number one. Number two, how it is related to PERT, that we need to understand. And this, when we make the connection, when we see that how they are related to each other, then we'll be in a very good place as far as this topic is concerned, right? So I hope everything is clear till now. So my dear friends, we are back, and now we will be discussing in very detail that what is normal distribution and how is it related to your project completion time. Fine. So very nicely you can see that this is now you can forget what we are discussing in PERT. Now you can completely forget, and now you can focus on what is this normal distribution all about. Now we will be discussing about normal distribution. My dear friends, first of all, let me write here that this is your normal distribution or Gaussian distribution, whatever you want to say. Normal distribution. Let me give you an example that many general phenomenon, they follow normal distribution, be it your marks that you are getting, be it your average IQ of the people, be it your heights of the people, be it your weights of the people. These things are, we say that it is normally distributed. Fine. My difference is the graph that you are seeing. This is the distribution pattern that you are seeing as far as your normal distribution is concerned, right? So clearly you can see my dear friends, what happens, we are generally provided with data, a lot of data, and I've already told you that the motive behind data is to find out where is the mean lying and where is the standard deviation lying. Let's say we have so much of data and we have managed to find out that the mean is, let me write it over here, the mean is mu and the standard deviation for this is sigma. For example, you have so many data, you have very much data, and now you can say that mu is the mean and sigma is the standard deviation. Yes, we can find out mean, arithmetic mean formula you can apply and find out. Sigma, you can apply the standard deviation formula, root over x minus x bar whole square 1 by mu, all this 1 by n. That formula you can apply and find out the sigma. I am not going into that much details into core statistics. I am not going. You can find out, and then you can plot, sir, why sigma is needed, why standard deviation is needed. Because it tells you that how the data are related as far as with respect to mean. From the mean, how your data are spacing themselves, it is given by your sigma, right? So clearly you can see that mu I have plotted over here, the mean, and in a normal distribution the mean comes in the, in the middle, right, middle of the graph. So this is not mu minus sigma, because when I go front it will be mu plus sigma. Let me use red. It will be mu plus sigma. It is mu plus 2 sigma. Mu plus 3 sigma means sigma, 2 sigma, 3 sigma. And when I go back, it is minus 1 sigma, minus 2 sigma, minus 3 sigma. This is way the normal. So what is the significance of normal distribution? First of all, the thing is, what is the significance? Normal distribution tells you that most of the data are in and around the mean. And we say now that suppose in your, you give any exams in your school, what did you observe? That let's say the class average is 50 marks. If someone says the class average is 50 marks, so you would see that if there are 50 students in the class, in and around almost 40 students will be in and around the average zone. Let's say from 20 to 80 marks, or let's say from 25 to 75 marks, 80 marks, most of the people would be lying. But only few students were there who crossed 90 marks, and only few students were there who scored, below 10 marks. So below 10 marks also, one or two or five students would be there, and above 90 marks also some students would be there, very few. But majority of the people would be lying in and around the average marks, and this is what this distribution would tell you, that majority of the data would be around the mean. Now the question is, sir, how much data? How much data would be around the mean? That I will tell you in some time. But now you need to understand what is normal distribution. What is normal distribution? So my dear friends, you can clearly see that when x is your random variable, this is what? Random variable. This fx becomes your PDF. What is PDF? Probability density function. Now if you are preparing for maths also, you can refer this video. This is your probability density function, and this is your random variable. Density function, this is not probability. If you are thinking that fx is probability, no my dear friends, it is not probability, it is indicator of probability. It is your density function. First of all, what are the characteristics of the graph that you are able to observe? So the first thing is that, sir, it is bell shaped. Sir, it is symmetric about the mean. Symmetric about mean. Now, it's an even function, most important. It's an even function. Also, my dear friends, whenever a graph is symmetric about the mean, we say that mean is equal to mode is equal to median for a symmetric graph, right? And I can say that the total area covered under the graph is 1. So all these things, my dear friends, you are able to tell regarding the normal distribution. But first of all, what is fx? Sir, when you are saying something as the density function, there must be some f of x. So that f of x is 1 by root of 2 pi sigma square e raised to power minus 1 by 2 x minus mu by sigma whole square, where x is your random variable, mu is the mean over there, mu is the mean, and sigma is the standard deviation. Now you would be asking that, sir, okay fine, this is not, this probability density function is not the probability. So what it is and how can we get the probability? Now it's a very good question, my dear friends, that the density function is given, all these things are given, how to find the probability? Now let me tell you one very important thing. Normal distribution comes under the category of continuous distribution function, and whenever continuous distribution functions are there, you don't find the probability on a single value, right? You are always interested in finding the probability between the range. Yes, my dear friends, this is the most important thing, that we are always interested that the value is lying in the range. You are always interested in probability for a range, not a single value. Sir, why? Sir, why? It is because in a continuous distribution function, the area under the curve gives you probability. Area gives you probability, not the function itself is giving you probability. I repeat again, my dear friends, in a continuous distribution function, the area under the curve gives you probability, not the function directly gives you the probability. Unlike in discrete model, the function directly gives you the probability. In a Poisson or a binomial distribution, if you put the x value, you directly get the probability answer. But over here, if this is the fx value, and if you are thinking that, sir, I know mu, I know sigma, if I put x value, I'll be getting the probability. No, it is not giving you probability. Rather, the area gives you probability. So for area, what do you do? For area, this is the function, and if I'm asking you find the area of fx between any two x values, so what do? You simply do integration fx dx, and let's say between x1 to x2 you are finding the area. So this is giving you the probability, not individual fx. And you can also make out from the word density na, density means what? Something per volume ना, we say density. mass को क्या बोलते हैं? Density per unit volume, as we say ना, mass per unit volume is density. So volume per unit volume, so when you are multiplying with something, then it gives you the probability. Fine. So sir, it means that we are never interested in a single value. No one will ask you that what is the probability of obtaining mu. No one will ask you that what is the probability of obtaining mu over here. No one will ask you what is the probability for obtaining mu plus sigma or for x1. Why, sir? Because probability is given by the area. If you find out the area for a single value of x, what is the area? Area is 0. Probability is 0. Getting or not? So we are always interested in finding the range. Fine. This is now concept number 1. Now concept number 2. Okay sir, we have mu plus sigma, mu plus 2 sigma, all these things are fine. We know that area is going to give the probability. That means if you feel that this is your area, is it visible? Is it visible? If you feel that this is your, I think it's not. So this shaded portion will give you some area, and as such it is giving you the probability between mu plus sigma and mu. So if you take this area, it will give you some answer, and accordingly between any two regions you can find the probability. Now my dear friends, what happens for every x1 x2, when you substitute over here, it's, if you see this function, if you see this function, you would feel that, sir, this is looking very clumsy. Means every time you are saying that we have to integrate that big function, and then we will substitute values and we get the probability. Yes, we have got the concept, but don't you think that it is very clumsy that such a big function is there? So we do simplification. we do simplification. What is that simplification? The simplification is, let me write over here itself. Let me write over here itself. What simplification do we do? The simplification is, we assume x minus mu by sigma to another variable, and that is z. See, sir, sigma is variable, mu is variable. No, my dear, it is the constants. You already know mu and sigma for a project. That is constant. X is initially your x was variable, and now z I am considering to be my variable. Sir, how it is getting simplified? See, these values that are there, that is for x only. But now your aim is to convert it to z. So these values that you have written, it must also be in terms of z. Common sense tells us that. So when you substitute x equal to mu over here, if you substitute x equal to mu over here, so what will happen if x equal to mu in this expression? So mu minus mu is 0, and then z equal to 0. If you substitute x equal to mu plus sigma, over here if you substitute mu plus sigma, so mu plus sigma, mu got sigma by sigma, z equal to 1. If you substitute x equal to mu minus sigma, z will be minus 1. If you substitute x equal to mu plus 2 sigma, z will be 2. And if you substitute mu minus 2 sigma, z will be minus 2. And so, my dear friends, just try to feel that I have only taken random values of mu and sigma, but I am getting one single value of z. It means, suppose you have two distributions, and for that two distributions you might have mu and sigma value different for those distributions, but when you ultimately plug in over here, you will get a single value of z, and that too not in terms of very big numbers, you are getting in terms of these small numbers, and that is 0, 1, 2, 3, 4, something like that. This process of converting from x variable to z variable is called standardization of a normal variable. And now, my dear friends, our entire x set has been replaced by z set, and that z set is known as standard normal distribution. Now we have shifted our base from x to z, and now, my dear friends, clearly you will find that now x has been replaced by z, and the mean is 0, 1. Now we have values in terms of 1, 2, 3. This is known as what? This is known as this is known as standard normal distribution. Standard normal distribution. Sir, why standard? See, something standard, you have standardized the normal distribution. Whenever you see the values, you words such as standard, so it means that you have standardized something. एक standard आपने set कर दिया है. That standard set of values are 0, 1, 2, 3, and all those things are there. So, my dear friend, this was my function. F of x is, what was my function? Should we write over here? Okay, no issues. Let me write it over here. Your initial function was 1 by root over 2 pi sigma square e raised to minus half x minus mu by sigma whole square. And now you have assumed this entire thing to be your z. Yes or no? You assumed x minus mu by sigma to be your z. So, my dear friends, can you tell me what is the standard deviation? Standard deviation means the spacing between the two x values. So it is what? What is the spacing? 1. What is the spacing? 1. What is the spacing? If you talk about magnitude wise, it is 1 only. Don't say -1, tell 1. 1. So if sigma is 1, so sigma square will be what? 1 only. Sigma is 1, so sigma square will be 1. So sigma square is 1. Now if I write in terms of z, it will be root over 2 pi and e raised to minus this entire thing is z, so z square by 2. This is your normal distribution function. Clearly you are seeing that from here it has got so much simplified, so much simplified. These values are also getting simplified, and now it is so much easy to do. My dear friends, see, the origin has shifted to 0, and clearly my dear friends, you know, you can tell very neatly that this is an even function. So what is the property of even function? You know that, sir, in even function, when you substitute minus x, it will be becoming fx only. Don't get confused that, sir, you have to write z over here. Fine, you are understanding that even if you write any variable, it will be this only. Second thing, it is the even function is symmetric about the y-axis. So you are seeing this is the y-axis, and clearly the two parts are symmetric to each other. Fine, all these things related to even function you know, and let me tell you that this is important in doing questions. This property of normal distribution becomes very handy as far as your questions is concerned, your numericals is concerned, right? Fine. Now my dear friends, we still don't have the standard values. So you will feel that, sir, we have standardized, but what is the importance of it? What is the where do we need it? How is it useful to us? This is the question number 1. How is it useful to us? First of all, my dear friend, dear friends, when you have one particular set of values, you have that when it is converted to standard normal distribution, I will have only these values no matter whatever phenomenon is there. So isn't it better that I already beforehand calculate the probability values, and someone let's say I have all these values, I have the function, I know that if I integrate it, I will be getting the probability. I know all these things. So what is the use? The use is, tomorrow someone comes and tell me, sir, I have found a phenomenon and it follows normal distribution. Can you tell me the probability between any two values? So what I have done, I have already calculated the probability using the standard values. I have already the data, and I will just I will make something like table, and when from the table I can say that, okay, I have the standard values, tell me your z value. Now you will not ask your x value, you will ask his z value. You will see z value and you will see that where is the probability, and you will tell the answer. It means that what I am trying to say, that no matter what phenomenon is there, no matter what phenomenon is there in the world, and if it is following normal distribution, you can refer to the standard normal distribution chart and directly tell the probability value. Sir, why? You have the z values, you can find the probability, you can make a chart, construct a chart, and just see. This is the benefit of standardizing your normal distribution, my dear friends. And for that matter of fact, I will show you the glimpse of the chart, that is the standard normal distribution chart. Yes, my dear friends, I know you are not able to see anything in this chart. You are not able to see anything in this chart, but it is just for your, so that you understand the things, that here I will have the z values and here I will have the probability values. I know it is not visible, nothing to worry, my dear friends, but these are just the probability values that you are seeing over here. Fine. So my dear friends, when you have all the values regarding to normal distribution, what do? We simply, when we have all the values, my dear friends, we find the value between minus, we are interested in finding that can you find what is the probability between z equal to -1 and z equal to 1. So what he will do, he will integrate between -1 to 1, he have the function, and he got, means we got that the value of probability is 0.674 between -1 to 1. So can you say what graphically, how, what graphically what do we want to say? Graphically, the area between -1 to 1 is 67.4 in terms of percentage, or 0.674. So sir, -2 to 2 is also possible. Yes, it is possible. So between -2 to 2, the area between the area of the graph covered between -2 to 2 is, where should I write? Over here I am writing 95.4 or 0.954 I should write. 0.954 is the area, and similarly between -3 to 3, when you cover the entire area, not entire area but between -3 to 3 only, some area is left over here, this area is 0.974. So I suggest everyone to just memorize these data, as questions have directly come from here as far as your normal distribution is concerned. So between -1 to 1, 67.4 or 0.674, between -2 to 2, 0.954, and between -3 to 3, 0.974. From where we have got it? We have got it from, as I have explained you, from the standardized table we have got. Now my dear friends, see one thing, I told you it's an even function, it's a symmetric function. How do we make use of it? How do we make use of this quality of the even function? See, if the area between -1 to 1 is 67.4, so can you tell me the area between 0 to 1? It will exactly be half of 67.4, 37 or something, 36 point something. If the area between -2 to 2 is 95.4 or 0.954, so the area between 0 to 2 will be 0.954 by 2, somewhere around 47%. Same for -2 to 0, and similarly you can make use of the even properties of your normal distribution. This is called making use of the symmetric properties, and that you will encounter so much often while doing questions of normal distribution, right? Fine. Till now I think you have understood very neatly what is normal distribution and its sub concepts. All the things you have understood very neatly. Now I will take you again to the concept of PERT. I will take you again to the concept of PERT and how it is related to the normal distribution. Now it's time to open up that. Here I have written the project completion time follows normal distribution, right? What is it? Project completion time. What is it? Project completion time. Sir, you are missing something. It is expected project completion time. It is expected. Now you will say that, sir, what is the significance of this word expected project completion time? My dear friends, expected means expectation. Expectation means mean. And where do we find mean in a normal distribution? Exactly at the middle. Exactly at the middle. It means that expected project completion time lies exactly at the middle. Clear? So in a normal distribution, you know that in the middle there will be expected project completion time. Number two, I told you that we cannot say with 100% that the project will be completed within the expected time. we cannot make a statement. It means there is some certainty level. What is that certainty level? Now, that certainty level is 50%. With 50% confirmation, I can say that the project will be completed by the expected project completion time. For example, in the previous case, I can say that the probability of completion of the project within 23 days is 50%. Why? Sir, because expectation lies in the middle z equal to 0. Now you'll ask me that, sir, from where this 50% you are getting? Everything is clear, but now you'll ask me that, sir, from where this 50% is coming? That 50% is nothing but the area left of mu. The area left of mu. It means that when I am saying that the project will be completed within 23 days, it means I am indirectly saying the project will be completed between 0 to 23 days. 0 to 23 days. 0 and 23 days matlab mean is over here. So 0 to 23 days the project. What is the area? This area is, my dear friends, total area is 1. I have told you. So symmetric properties, even properties, if you draw a line in the middle exactly, you will find that this entire area is 50%. Now I think that every concept is connected. Every concept is connected to each other. And from here only the second concept arises. What? That, sir, if the project completion time probability, matlab if the expected project completion time is 23 days and probability is 50%, it means you can also find the probability for completing the project in 25 days, 23 days, 27 days, 28 days, 30 days, anything you can find out. Yes, sir, you can find out any project completion time with this. Now, how can we find that? That's the $1 million question. That's a $1 million question. That's a, how can we find that? Yes, that's a $1 million question. Now, my dear friends, let me tell you, whatever, see, whenever the question is giving you, whenever question comes to you, it will be in terms of x. X means this normal x values, 50 days, 23 days, whatever. But when you have to find that, what is the, when you have to find the probability, we have to convert it in terms of z. Sir, why? Because I told you, see, how did we find the area? We found the area by first converting it to z. Z equal to 0. I found the integration, I found that it was 50%. So whenever you get some other x value, you have to convert it in terms of z, and then only you, sir, after that what? After that you would be referring to this chart, which is your standard normal distribution chart, and from here you will be telling the answer that, okay, the project, the probability of completion of time within 30 days, 40 days, 23 days, 25 days, any days is this. Is this clear, my dear friends? Is it clear? Is it clear, my dear friends? So I am again repeating the entire concept, that I'm again repeating the entire concept. I'm again just I'll make you go through the entire concept. I have this project, I have completed within 23 days. So from normal distribution chart, that will lie exactly in the middle. If you refer standard normal distribution, exactly in the middle, left area is 50%. The question can be that, okay, what is the probability of completion time? You have answered that, fine. And the next question will be, what is the probability of completion of time for any x day, for any day, any day, any day? So for any day, what do? You convert all your x values to your z values, and from that Z value you refer to this standard distribution chart, and from here you tell the answer. Now as far as gate is concerned, I don't think any question have come where they have given you this chart and they are asking you, but the possibility is always there. So you need to see that the chart values, and then you can tell. I will just give you an example. I'll just give you an example. We'll solve this question, don't worry. I'll give you an example. For example, see, this question came in 2021. This question came in 2021, and see how smartly they are asking you the questions. The question is activities ABC form critical path of project PERT network. Mean variance for each activity is given, and what is the, see, this is activity ABCD. He is saying that it is the critical activities. Mean is given, variance is given, and they are asking you the probability that the project will be completed within 40 days. Within 40 days. So how to do this question? Dekho, for any x days, if he is asking you the probability of completion for any x day, what is the what I have told you? I have told you that from x to z we have to convert. From x to z we have to convert. Okay. Sir, how to convert from x to z? You have this wonderful relation, my dear friends. You have this wonderful relation that z is equal to x minus mu by sigma. So first I need to know what is this z value. X is already given, sir, 40 days. So first it means that I need to calculate sigma, I need to calculate mu. These two values I need to calculate. Fine. So what is mu? Mu is nothing but the expected project completion time. So sir, ABCD is already saying that, sir, it is in the critical path. So no need to draw any diagram. Simply add these days, and sir, you told 3 time estimates will be given. No, don't worry, he has already given you the expected time for activity. Why you are trying to work very hard? So simply add these days. So 6 plus 11 plus 8 plus 15, this is equal to 40. So mu is equal to 40. Mu is equal to 40. Sir, sigma also we need to find out. Okay. Sigma also you need to find out. But how you will find the sigma? Sigma is root over. Okay. No need to do root over. Simply you add the variance for this. Variance is 9 for 13, 13 for 17, 17, 9, 26. 26 you have got. Sigma square is what? 26. Variance of the project is 26. So what is the standard deviation? Standard deviation is root over 26. You get the answer. Fine. So sigma also you have found out. Mu also you found out. Next I have to substitute over here. So what is the x value that is given? 40. What is the mu that you found out? 40. What is the sigma you found out? Root 26. So ultimately it is coming out to be 0. And can you tell me z equal to 0 corresponds to what? You don't need chart for this, my dear friends. You know very well that z equal to 0 falls where? Z equal to 0 falls exactly in the middle, and it means what is the probability? Probability matlab 0 se you will always start, na? From left hand side you will always start as far as your area is concerned. See, not that always in whenever a maths question comes in engineering maths, not that area always you have to start from the 0 only. No, it can be between any two x values. But as far as your PERT is concerned, your industrial engineering is concerned, the days you will always start from the, if I am saying that I am able to complete a project in 15 days, iska matlab kya hai? Iska matlab 0 to 15 days na. Are you getting or not? So in over here you always start from the left. So z equal to 0 matlab kya? 0 se left, what is the area? Area is 50%. So So z equal to 0, z equal to 0 corresponds to a probability of 50%, or in terms of, see, he has given in terms of between 0 to 1, don't write 50%, between 0 to 1 it is 0.50, it is 0.50. Now you will ask me that, sir, now you told that you have to refer standard chart, but this question was very easily solved without the standard chart. It means we don't have to standard chart questions will not come. Sir, we cannot say that with accuracy. You are very lucky, we were very lucky that in this case we are able to do it without the help of any chart, but the scenario is possible when you can get a question something like this. Yes, my dear friends, there is a complete scenario. Now you will be asking me, sir, from where, what is this question? This is the question of UPSC in IAS. This question has appeared, and see what he is asking. First, this is the data that he has given to you, and then he is saying draw the network diagram. He is saying draw the network diagram, project completion time he is asking, and then he is asking that what is the probability of completion of project between 15 to 20, between 15 to 20. Yes, my dear friends, for this you have to refer standard chart. Don't worry, don't say that, sir, don't think that you have to remember all the values. They will be giving you the chart, you just have to see and tell the answer. But see, they have asked you in GATE. I don't think they have asked till now, so you need to be ready for that. You need to do questions like this, so that if they give you in case, and not only here, it can be in engineering mathematics also, in engineering maths also, they can give you a chart and they can ask you questions that tell me, for in that case you have to refer the chart value and tell the answer. So I hope, my dear friends, the entire concept of normal distribution and its relation to PERT, is clear, and in future any question comes related to this, you will be in a very very good state to answer that question. Is it clear or not? Is it clear, my dear friends? Is it clear? I hope if you're seeing this video, this entire topic, and you will feel very confident while dealing. So what did we learn today? We learned today that normal distribution becomes the most important thing as far as your PERT is concerned. That statement is such a big statement that project completion time follows normal distribution. It itself means that you need to know everything as far as your normal distribution is concerned. So not only in industrial engineering, in anywhere, in engineering maths also you can apply this fundamental. These two are basically the same thing only, but you can do questions of engineering maths also from this concept of normal distribution, right? Tomorrow I'll be showing you how normal distribution is related to your inventory. In inventory model, where normal distribution comes into picture. And most importantly, my dear friends, tomorrow I'll be discussing the basics of queuing theory. Now, queuing theory is not the queuing theory you read as it is in your just few formulas. Queuing theory, there is another distribution which is there, Poisson's distribution. And I will tell you tomorrow, I will show you how Poisson distribution and exponential distribution are related to each other, how these two distributions are applied in queuing theory, what is the relation between what is the relation between exponential distribution, Poisson distribution, how you can obtain one distribution from the other distribution, what is rate parameter. All these things, my dear friends, I am going to discuss tomorrow, and you will feel that your concepts are very much enhanced after attending the lecture. So today I am going to end the lecture over here. In case of any doubt, you can ask in the comment section and I will personally reply to you. And if you are finding these sessions to be useful, please share it with your friends, and with anyone in your friends who are preparing for GATE exam. He or she might find useful. You may help them as far as their preparation is concerned. So with this note, my dear friends, I am ending today's session. All the very best, prepare well, work hard, God bless. Thank you.